Welcome, .NET friends from all over the world. We are excited to have you here yet again. If you're tuning in for the first time, what is this? Well, this is the On .NET Live show. Our mission here on this show is to empower you, the .NET community members, to achieve more. I'm your familiar host, Scott Addie, and I'm joined by co-hosts Cam Soper and David Pine.
Hello.
We have a super interesting show today. So as a .NET customer, you probably know home automation is one of the lesser talked about, but probably most cool use cases for the technology. Here today to talk about this is our friend Leonard Sperry. Leonard, would you like to briefly introduce yourself to the audience?
Sure. My name is Leonard. I am a .NET principal .NET engineer. And I've been in .NET for quite a number of years now, working as architect and principal engineer. And in my spare time, I like to work on my home automation, make sure that lights turn on and off automatically, send myself alerts, all kinds of different things. And I wanted a better way to interact with my home because I am a .NET engineer. It's what I know and it's what I love. So I wanted to be able to write automation. So in order to do that, I wrote myself a framework and shared it with everyone.
So in the pre-show, we were talking about the wonderful display case behind Leonard. We're going to do our best to not geek out on the Star Trek memorabilia in there. But I guess, why don't we start? I know, Cam, you're a home assistant geek as well.
You spoiled my trivia question, Scott. I was going to ask you.
Go ahead.
You can pretend like you don't know the answer to this one. Do you know, Scott, what the most contributed, the most popular project on GitHub by contributions is? It used to be Visual Studio Code.
VS Code would have been my guess.
You're muted.
And David's muted, so his vote doesn't count.
Yeah, I was going to say VS Code. What are you going to say? Something else is more?
It's Home Assistant.
No way, really?
Yep.
Wow, that's incredible.
Yep. So for those of you who don't know, Leonard and I are both users of this open source platform. It's out on GitHub. It's a very, very, very vibrant contributor community. If Leonard's going to show you a lot more about it, but I want to make sure everybody's aware. This is for everybody. If you've got gizmos in your house that you can control remotely, this platform is for you. And what Leonard's going to show us is some really cool way to tie it in with .NET. So just setting the stage with that. Leonard, what do you got?
All right. So over here on the screen, I've got a Home Assistant instance up. Home Assistant, you can run it in various different ways. You can run it in a Docker container. You can run it on a Raspberry Pi. That's what I have set up. They have pre-built hardware that you can buy. There's one called Yellow and one called Green. I've got a Home Assistant Yellow. So what you're seeing here is a web page that is served up from a Raspberry Pi in my home. You see all the different lights that I've got in there. Got the smart plug, so that turns on the light back there. So that's not an automation. That's just raw Home Assistant functionality that's right there. So you can buy contact sensors and motion sensors and any kind of smart light that you can think of, smart speakers. You can plug them all into Home Assistant.
I just want to go ahead and put this on record. We're like 3-4 minutes into the show, and technically you've already done the first demo successfully by toggling a switch. I mean, there's been shows we've had in the past that we haven't gotten this far in and had even code shown or anything, but like you just had a working demo. That's so cool.
Thanks. So yeah, this is Home Assistant. And then there are different ways that you can write automations. Actually, if I come over here and say settings, not that one, sorry. Automations, you come into automations, you can create a new automation. You say, it's basically if this, then that. You say, I want to add a trigger on a device, like say the office door is opened, then turn on a light or something. It's very click and drag kind of thing. It's got other kinds of features in there, so you can like control devices by label. So if you've got a bunch of different devices that you like, I've got one for bedtime routine. So I tell the smart speaker, hey, it's time to go to bed, and it'll go through my house and turn off all the things with that label assigned to it. But it's very, very click heavy in here. And if you want to do anything in code, you have to do it in YAML. And if you want to do anything extra advanced, like put some math equations or something in there, then you start getting into having to embed Python code in the middle of your YAML. And as a .NET dev, I want to work in C#, you know? So
love that.
Instead of doing automations that way, I have this. So this is actually the automations that are running in my home. I have all these different automations in here. I can turn them on or off. So like Kazul is our bearded dragon that we have. We have an environment set up for him. I can go take a look at all the different times that different checks were happening on his environment to make sure that the heat bulb isn't burnt out and that kind of stuff. So yeah, this is all this stuff here. Any questions on what Home Assistant is before I jump into some code?
I guess one question for the viewer out there that might be hearing about Home Assistant for the first time, how would you go about getting started with something like Home Assistant?
That's a great question. The easiest way is probably like do what I did, get the Home Assistant Yellow. But there's plenty of documentation out there on how to get it spun up in a Docker container. So if you're comfortable running a Docker container, you can run Home Assistant. That being said, there's different protocols that you might want to work with. If you've got Wi-Fi devices, those are super easy. They'll just work with Home Assistant. But if you want to get into some of the other types of devices out there, you might need to buy some specialized hardware to work on those radio frequencies. But anything Wi-Fi or anything that's like you can pull data off the internet, there's probably an integration for it, and you can plug it into your home.
And then we have one question I see already in the chat that was likely to come up. It already did. The aspect of security. Is Home Assistant secure, and how would you lock this thing down?
So Home Assistant it runs on your private network. I would say make sure your home is secure. I wouldn't consider myself a security expert in terms of network security and whatnot, but it runs local. It doesn't run in the cloud. So that's one of the other advantages of Home Assistant is like if you tell your smart speaker or something that is using a cloud provider, in order for any interaction with your home to happen, it has to bounce out to the cloud and back. Home Assistant runs 100% local, and they actually pride themselves on privacy. So if you don't want it exposed at all, you don't have to have anything exposed to the outside internet.
Awesome. Cam, I see you were trying to say something over there.
Yeah, I'm going to add on just a little to that. So to Leonard's point, they've really gone all out to make this project something that you can run on any environment, and lots of different ways to set it up, right? You could set it up on, your own Raspberry Pi, just like by downloading the repo and running it directly. They have an image that has, I forget what they call their OS, like Home Assistant OS or something.
OS.
Yeah, HasOS. They have an image that runs their version of Linux that has everything pre-set up, and then it also has kind of a container environment for running add-ons. Like there's a lot of Leonard was talking earlier about Z-Wave and Zigbee devices. Yeah, there we go. There's the add-on library. Like the all these different add-ons that you can bolt on to the Home Assistant operating system. In my case, I run Home Assistant in Docker, and I have a bunch of other stuff running in Docker. And some of these add-ons that Home Assistant OS offers, as like click here to run this too, I run those in separate Docker containers. So there's like a billion different ways to do it, and that extends to security too. So like personally, I just subscribe. The Home Assistant project, they have one of the ways they fund their project is they offer a membership to use their remote access service, the Home Assistant Cloud, also called Nabukasa. It's pretty affordable. Many folks would prefer to just set up their own and get their own SSL certificates and everything if they want to do remote access. I just do Nabukasa because it's easy. It's a few bucks a month, and I don't have to worry about it.
So Cam, you mentioned this is affordable. What cost is involved for someone that wants to do something like this?
Zero. Like to get Home Assistant itself is a free platform, and like Leonard said earlier, all these different Wi-Fi devices you have in your house, if Home Assistant doesn't support it directly, chances are there's somebody out in the community who does, right? Somebody out in the community has made an add-on that you can usually install through what Leonard's showing on the screen right now, the Home Assistant Community Store, and that will integrate whatever other services that you have. Like, for example, see that GE Home Smart Appliances option right there. That is a community provided integration. And I know I don't know what Leonard's using that for. I know I use it. I have an ice maker that I got from Costco. Nothing that a lot of people own, so it's not like got built-in support to Home Assistant or whatever, but somebody in the community has the same appliance and they're like, okay, well, we're going to get this thing exposed in Home Assistant, and here's a little bit of code that you can install in your Home Assistant installation to configure that.
I use it for my washer and dryer.
There you go.
When the laundry is done, it turns a light in my living room blue and announces on the speaker that wet clothes need to move to the dryer, unless the dryer is already running, and then it says the washer's done, but the dryer's still running. And then as soon as you open the washer door, that actually clears the notification, so the light will go back to its normal state.
Very cool. And I think what Leonard's going to show us here as .NET developers. So this is the Home Assistant project is all built in Python. All the add-ons are built in Python. The SDK is all Python. If you're going to contribute to this project, you need to know Python. But Leonard is one of these people like me who are like, okay, this thing might run Python, but when I write code and I want to automate stuff in my house, I'd really kind of prefer to do it with .NET, just because that's what I'm super comfortable in, and I know all the libraries that I can install and do, various connecting to cloud services or whatever I need a .NET library for. And I think, Leonard, you came up with a kind of a unique solution to that, right?
Yeah. So a lot of people, there's different frameworks out there for writing automations. And I want to be clear on this. HaKafkaNet is something for writing automations. It does have a dashboard, but it's not really designed to be like a dashboarding platform. It's designed to do those things that you never want to touch. Like when you walk into a room, I want the light to turn on. That kind of an automation. So it's an automation framework. And there are lots of different automation frameworks out there for just about every kind of language you can think of. A lot of them are using MQTT. And there's a very robust set of community support for MQTT specifically. When I was looking, I was like, well, I want to do a little bit more. Partially, I just wanted to learn some other things, and I wanted to kind of push the boundaries a little bit. And I discovered that there is actually a Kafka integration out there. So if you've got Kafka set up locally, you can have Home Assistant pump all of the state changes for all of your devices out to Kafka. And that's what my framework is doing. It's reading off the Kafka. Now, some nice benefits of doing it that way is, as opposed to MQTT, because MQTT is a messaging platform, whereas Kafka is a forward-only data stream. They're both messaging platforms, but they work very differently. Kafka has state that it will hold on to. And so I can actually shut my application down entirely and restart it, and then read the Kafka queue from the beginning and load all of the state for all of the devices in my home into the framework.
You're muted again, Cam.
Of course I am. So let me ask you this then. So say I've got an automation that is it relies on a series of events happening, right? Like a door opens, a light comes on, and then I want to wait for the door to close and the light to, and that's when I want to turn the light off, right?
Mhm.
So in Home Assistant, like I could do this in a Home Assistant automation really easily. Home Assistant, all of its everything behind the scenes, configuration, automation, everything is YAML, but they give us some really nice user interfaces to build them. And we could build that kind of automation pretty simply. But the problem I have with an automation like that, Leonard, is if I have to restart Home Assistant while the door is open, right? So I open the door and the automation says, okay, the light is on, and now it's going to wait for the door to close. But I restart Home Assistant, right? I've installed a patch or something. It's going to forget that door is open and that it was in the middle of an automation, right? It's not going to be able to pick up where it left off.
Right.
So what I'm hearing is that you have solved that problem.
I have solved that problem. Just about any kind of scenario that you can think of, HaKafkaNet can handle in that regard. So when the application starts up, the first thing it does is it goes out to Kafka. It starts reading things from the beginning. As it's reading state changes, it also will dump the message into an iDistributed cache. I use Redis for mine. You don't have to use Redis, but if you do have something like a Redis that will stay online while your application is restarting, then when it starts up, it'll go out to the cache and go, oh, I already took care of that one. I don't need to do that one again. Until it gets to one where it hasn't handled it before. It's like, oh, that's a new one. That's not in my cache. Did that happen before startup or at startup? And it's aware of these timings. So there is, maybe this is a good time to jump into the code. Let's come over here. Oops. What is it? Automation runner. Trigger was it? I don't know why it's not there, but it's the event timings. The event timings, it'll be aware of, is it cached? Is it before the cache, after the cache, or is it post startup? And then depending on what you specify. Oh, I know why, because it's a part of automation. So if I navigate to the interface, my automation base actually, there's this event timings enumeration. And so it knows, it assigns it a timing. And so if your automation matches the timing of the event, then it triggers the automation. So you can choose to ignore it. Like by default, it's just grabbing everything post startup. But you can grab things that are pre-startup. You can grab the pre-startup same as the last cached, or ignore that one and say only choose new ones. You can pick and choose whichever events you want.
That's interesting. Yeah, we have several questions coming in. One of them from our good friend Blake. I'm going to change the layout here real quick. Fellow Wisconsinite. As a very heavy user of Home Assistant with several hundred automations and hundreds of devices, why would I want this technical debt? Well, first of all, I don't think anyone wants technical debt. But yeah, so I guess what do you think of that?
It's an interesting question. I have maybe a few dozen automations. I don't have hundreds. In a situation like that, I might be kind of particular about what I want. For me personally, my Raspberry Pi can only take so much processing power. So I use Home Assistant as like my hardware interface. And then I've got this running in a Docker container on a separate PC. So it takes care of all that processing power. So that might be one reason you might want to switch to something like this. The other thing is, like, Home Assistant does a lot of things really great. Like, if you want the light to turn on when motion is detected and you don't want to have to worry about, like, if the system was down, like something that happens really, really fast, it's maybe something you want to keep in Home Assistant. But if you want to do things that are more advanced, you want to go reach out to web services or other services you might have running in your home, anything complex, like anything you can do with .NET, you could use it to control devices in your house.
Got it.
I think this answers some of the same kind of, if you're an existing Home Assistant user and you're already in that community, you're probably aware that a lot of people use, instead of doing automations in Home Assistant, they'll use Node-RED, which
Right.
Node-RED, if you're not familiar, is it's a message processing platform that is, it's coding by flowchart. Essentially, it's allows you to do some pretty complex stuff that you can't do easily in a Home Assistant automation. So there's a lot of people in the community that use Node-RED to do the more complex stuff. Where I think I see, Leonard's platform kind of answering some of that same niche, but from a .NET perspective instead of from the Apache flowchart perspective.
Yeah, and actually, one of the very first automations that I wrote was, I've got solar panels on my roof, and I wanted to use them as like an luminance sensor, so I know how much light is coming through the windows in my living room. So when the sun starts going down, I want to turn on the lights in my living room. But I noticed that when they came on, they kind of came on really bright. And so I wanted them to kind of more gradually come on. And so after it calculates the difference, it plots that to a parabolic curve. So the lights come on nice and gradually. And to do something as simple as that, like I just want X squared. And having to do that in YAML, in Python, like there's better ways to do it. I knew there was better ways to do it, so I wrote it.
Yeah, honestly, as I'm sitting here thinking about it, I start thinking about the automation that would take, and it would be a really complex YAML file that I don't even want to think about. So certainly, I think your solution there is better for stuff like that. Absolutely.
Awesome. Yeah, we had an earlier question also from Jose on YouTube, who's saying, great job first of all, but do you use STM32, ESP32, or Arduinos, and how do you communicate with them?
So yes, I do have some ESP32 devices in my home. For those that are not familiar with what ESP32 is, it's basically like a mini Arduino. And then you can go buy sensors, motion sensors, whatnot. I put together a couple of wave sensors because those things are still quite pricey, and I could build it for half the cost and get to play with the new technology. And so I use Home Assistant for that. Home Assistant is like I said, it's my hardware interface. So if I want to have any kind of a motion sensor or any kind of a smart device, I connect it to Home Assistant and let it do its thing and work with all those low-level protocols. And I work with turn it on or off.
Particularly when it comes to ESP32, the Home Assistant project has a sister project. I don't know what you would consider it, but they have another project called ESP Home. And ESP Home is it's ridiculous. So you basically it's a configuration file, and you describe what you need it to do. That you need it to be able to turn pins off and on, or that you need it to communicate with a certain protocol with a sensor to get sensor data. And this is all declaratively describing what you want it to do. There's no this is all configuration. There's no like actual code involved. And then what ESP Home will do is it will actually build the image to flash onto that ESP device, and it automatically integrates with Home Assistant right out of the box. Like as soon as you flash that device and it comes back up, it's exposed as entities in Home Assistant.
Yeah, so just like Kim was saying, like here's a binary sensor for this LD2450. That's a wave sensor. And you declaratively say how you want it to work, just like this. And then Home Assistant will actually compile it and then flash it to the device for you. That's actually the only time that my Home Assistant is super taxed, is when it's compiling one of these and sending it off to the device. So I guess the next thing to cover now, I think we're pretty familiar with what Home Assistant is. Probably jump into like, okay, well, how do you write an automation? What is an automation? So let me go ahead and grab this here. So HaKafkaNet exposes this interface called iAutomation. iAutomation, you already saw me briefly go into it. It has an automation base here. There is, yeah, and then there's a simple automation also that you can have, but there's one more thing in here. So yeah, there's a couple of things that it has. It's got this execute method, and it takes in a state change. So your device changed from off to on. So there'll be an old and a new property exposed in that state change. And then it also has in the automation base, the event timings that we already talked about, and then an IEnumerable of strings, which is the triggering entities. So every device in Home Assistant has an entity. So if you specify an entity that you want to trigger an automation off of, and you specify the timing, and then you specify that execute method, when that device has a state change, then your execute method will be called. So in this case, I have a demo contact sensor. You saw me turn on this light back here before. I did that through the Home Assistant dashboard. This time I've got a little contact sensor. So it's like something that you could put on a door. So I say when this thing has a change, execute this method. Here I'm saying go take that state change and turn it into something that represents on off. Because you can have entities that are like thermometers. So the state of the entity might be a number. In this case, it's going to be on or off. And so if it's on, go turn on the smart plug, which controls that lamp. Otherwise, turn it off. And so if I fire this guy up, give this just a moment for it to load up. So now this is the dashboard for this instance that I have. You saw previously the one that I have for my home. This is for this development environment right here. Sometimes it can take a little bit for this state handler to get initialized. I've noticed that if you shut it down and restart it again real quick, then the Kafka clients need time to like figure out where they're at. But if you've had it shut down for even like 30 seconds, it usually fires up like almost immediately. So in this case, it is initialized. So now if I grab this contact sensor and I open the door, it turns the light on. It's that simple. Everything comes back to that iAutomation base. There's other kinds of automations, but at the end of the day, they're all coming back to that. Device changes, trigger a method.
So now this is running. You said you've got this running in a container or locally or.
So this, what I just showed there is running right here in Visual Studio. But for my home, I actually have a Linux box that I run on. It's actually got a mobile processor on it. The whole thing uses all of 10 watts. It's got 32 gigs of RAM in it, but it's running off this quad-core mobile processor. And I've got about a dozen or so Docker containers that it runs in. So for me, when I go to deploy it, it's Docker Compose build, Docker Compose up-d.
Right. So just to lay things out here for folks that are drinking from the fire hose, right? Because there's a lot of comments of I've never seen Home Assistant. So Home Assistant is the platform that does home automation, that integrates with all these different devices out there. And your project here, HaKafkaNet, lives in a separate process, maybe on a separate box, and it watches. What's it do? Subscribe to the event stream on Home Assistant, I guess.
The Kafka queue.
Gotcha.
Yeah.
So it essentially watches that queue in Home Assistant to watch for any devices changing state that it has an interest in, right?
Yep.
And then when that happens, it fires off fires off whatever automation goes with it that implements this iAutomation interface that apparently has an execute method. Is that right?
Yep. That's exactly it. Yeah. And because it takes a dependency on Kafka for reading the events, and then the change devices, it takes a dependency on Home Assistant's RESTful API. So as long as Home Assistant is up, it can communicate to it. And even if Home Assistant's down, it can still read from the Kafka queue.
Gotcha. So, and just for folks who aren't familiar with Kafka, just like a 30,000 foot view of what that is.
Yeah. So I would not consider myself a Kafka expert by any stretch of the imagination. But like I said before, it's kind of like a messaging platform, like MQTT. The big difference is, at least in my view, is in MQTT, when you send a message and you handle that message is gone. It's never coming back. Kafka is a forward-only data stream. So it represents the state of all of the entities that you have. It also has this concept of a key. And in this case, we're using the ID of the entity in Home Assistant as the key. And so we compact the topic, which means in Kafka, we keep the most recent version of a message for any given entity. So it's always keeping track of whatever the latest is. And then when you start your application, you can read that from the beginning.
You got any other cool automations to show us?
Yeah, I got plenty.
Awesome.
So this is the iAutomation interface. Like I said, I wanted to show that one because that's kind of what everything comes back to. But over time, I've added to this framework. I added quite a bit more. We've got conditional automations, schedulable automations, and all three types of automations can be non-generic like this is, or generic. So instead of having to convert it to on-off, I can make it so it's already an on-off entity. In addition to that, what I found pretty early on when developing this framework is having one file for every single automation was a bit tedious. And that was one of the things I was trying to get away from in Home Assistant. I wanted to go a lot bit easier. So there is a concept of a registry. So if you implement this iAutomation registry, it has a register method, which gets past a registrar. And the registrar has a couple of different methods. This is the one that I recommend using, is this try register, which takes in an enumerable of functions that return automations. And the reason why I recommend this one is because when it starts up, it'll basically wrap each one of those function calls in a try catch. And so if for whatever reason during startup your automation failed or threw an exception, it won't prevent your entire setup from starting up. It'll start up everything that it can. So with the try register, I've got this set color light and also this say something here. So this is a simple automation. I'm using here the automation builder, which has got a bunch of methods on it. You say, hey, builder, create me a simple automation. I want to set the triggers. I want to set the execution method. And if I want to do other things like set the name of it or change the timings of it or the automation mode, there's a lot of different things you do real quick in here. I've also got this other one here, say something. It's taking in a generic date time because it's one of the quirky things of Home Assistant. If you've got a button like the scene controller here, and you click a button, the state for that entity is actually a date time of when did it fire. So I've got these two automations. So I'll go ahead and start this up. And while it's starting up, I also want to show that, this, my colors, is actually an enumeration that I defined here in this project. So I can strongly type things that I create in Home Assistant to anything that I need. So for example, I've got a Sonos speaker. That Sonos integration has very specific properties that it exposes. It's not something that's all Home Assistant users are going to use. It's something that I have. So I've been able to extend the framework to add in like the Sonos properties for my Sonos speaker and get that strong typing. These here are representing this dropdown that I set here. And so I've set it up so that when you change this dropdown, it's got a bunch of different colors. It'll change this light up here. Now this is a virtual light. The things on the left side of the screen are actually like devices in my office here, but things are on the right. These are all virtual. So if we've got an idea for an automation we want to write, we can quickly code it up right here, right now, and you can see it. So in this case, it happened that fast. Oops.
So just explain, like once you actually change that dropdown, it's not simply just changing what's rendered on the HTML there. It's actually doing like a whole message loop, right?
Yeah. So this is changing the state in Home Assistant and then dropping it onto a Kafka queue. And then on a separate machine, I have this machine, I have it running, listening to that Kafka queue. It's picking that message up and saying, oh, I need to go execute my code. And then the next thing it does is it makes a, let's come back here. Services API turn on light. In this case, it's that virtual light, and we're going to set the color name to the thing that was in the dropdown. So yeah, it's going out to Kafka, then to mine, then making an API call back to Home Assistant. And Home Assistant's updating the UI.
And it's so snappy because it's all on your local network, right? And everything's up and healthy, so it's just seemingly instantaneous.
Yeah, no hops out to the cloud here.
Right. Love that.
We have a question here. We're actually seeing a couple of questions. I'll pop this one up on the screen from our friend Frank. He's asking about Kafka. Where are you running that, and is it complicated to set up?
The very first time I did, yeah, it was a little bit complicated, but I've made it easy. At least, hopefully, I've made it easy for you. So I've got this other, excuse me, this repository, which I've actually made public. So if you want to see some more complicated types of automations, you can go find the repository for my own home. And in that repository, I've set up HaKafkaNet as a sub-repository. In that repository, there is, excuse me, there's an infrastructure folder, and that infrastructure folder's got 2 files in it. So I guess this would be a good time to cover, what is it, assuming that you've got Home Assistant already stood up, what does it take to stand up HaKafkaNet? It takes 2 files, some way to manage Docker containers, and your place to execute .NET code. That's it. For setting up Kafka, I've got a Docker Compose file already set up for you. So you basically go in here, change a couple of things. I've tried to comment it to let you know what you need to change. You're probably going to change this to match your network. This one actually also starts up a Kafka UI instance. So, excuse me, this is also running on my home network. So you can see Home Assistant states, if I want to go look at the messages, I can actually take a look at the live mode. And then as things are happening in my home, these are actual events that are happening in my home right now. So like Kazul, I told you he's our bearded dragon. He's got a power strip. It was reporting that there was a change in the wattage that it was reading. So this is all the events that are happening in my home. So yeah, you spin up a Docker container, and then you add 1 file to Home Assistant. Those who are familiar with Home Assistant will be familiar with the configuration.yaml file. It's pretty important to Home Assistant. You basically add this to your, this 1 file here to your configuration.yaml. If you go to the documentation in the repository, there's actually a page on getting started that shows you how to set this up as its own file so that you can keep it separate from your main configuration.yaml file. And then, yeah, you basically, you point this at your HaKafkaNet instance. You tell it, or no, sorry, this is the Kafka. So yeah, you point this at Kafka. You tell it what domains do you care about. In Home Assistant, there's a concept of a domain. So there's a light domain. All of your lights will be in, it'll be light.device ID. Binary sensor is going to be things like your motion detectors or your contact sensors. The sun is its own little thing. So you can run automations on sunrise, sunset. There's an interesting little thing there too, Cam, we didn't cover before, is that because HaKafkaNet is knowing about all of the states, when it starts up, it can schedule things out in advance because it knows where the sun is. Mm-hmm. So it knows based off of the information coming from Home Assistant, when is the next sunset, and it'll schedule an automation to run at sunset. something that HaKafkaNet can do that others can't do is it can actually say, I want to schedule something 15 minutes before sunset.
Yeah, no, I've had a lot of problems with that exact scenario actually, because I have my living room faces south, and I have smart blinds that I want to adjust during the day based on where the sun is, right, and whether or not it's shining through my southern facing living room window. So I have tried to game that out just by basing it on, you know, time of day and sunset, right? But yeah, being able to schedule things relative to sunset would make it a lot easier.
You want to
then
see how easy that is in
Yeah.
HaKafkaNet?
Sure.
Yeah, show us that, and I'm going to just share a random thought I had about AI taking over the world. But wouldn't it be cool if, like, we could, you know, integrate more AI, everything, but like using some of those like inferences and like the ability to track the sun, and maybe like, you know, Cam's south-facing blinds. Like, if you give it enough metadata and like information, couldn't like these things just start to get really smart and like optimize the heck out of everything and like just make it super efficient?
So we're kind of getting there. Funny you should mention that. Home Assistant, the project maintainers every month. Well, first of all, they do a release every month, but every month they focus on one particular area. And last year, was it last year, 2023, I think? The whole year they called the year of voice, right? It was all about voice interaction, and they've got it now to where you can, just like you integrate, like you know, Leonard showed us earlier, the GE integration that points to, you know, his washer and dryer. You can integrate Google generative AI directly, just as an integration now, and have it replace Home Assistant's built-in voice assistant. And you can, it gets really crazy then, because you can be very non-specific. You can just be like, yeah, turn off all the lights in the living room, and it'll like determine by clues on the entity names and entity descriptions and the areas that are set on the entities what the lights in the living room might mean, and just take the best guess.
That's really cool.
And of course, I typed the wrong thing. There you go. Wrote your automation for you.
That was quick. So let me see if I can. So what are we doing here? Can you walk me through the code?
Sure. So HaKafkaNet gives you a couple of different things that you can inject to any of your automations or your registries. The two things that I recommend are the startup helpers and the HA services. So there's a couple of different things in those two interfaces. They're basically wrappers around other interfaces to make it easy for you.
Mm-hmm.
In this startup helpers thing, there is a thing called an automation builder. So I'm going and grabbing that builder, and I'm saying create a sun automation. And I want to go it off of a sunset with an offset 15 minutes before sunset. Go turn on the front porch light.
Very cool.
So you could do this with like holiday lights or anything that's automatable, right? Like,
oh yeah, sure. Yeah, if you got a holiday light fixture and, you know, around your house, you could do some really amazing stuff with this.
Or like if you've got even like locks, like smart locks,
Mm-hmm.
you could just have like a global one that's like, you know, before dark, if you've forgotten to lock the doors, like it just automatically closes them at, or like whatever time you want.
Yeah, I've got that wired into my bedtime routine. So I say, get ready
that.
for bed, and along with turning off the lights, turning on the one light by the stairs so that I can get up to my bedroom, locks the front door, checks the garage to see if the contact sensor on the garage door is closed. If it's not closed, it'll actually turn on the light by the back hall to light up so that I can walk to the garage to go close it. And then 30 minutes after that, it'll turn off the lights by the stairs. It does all of that in one automation.
That's incredible. Yeah, that reminds me of some of the stuff Cam had shared with me before about his house. Like he gets like text messages about appliances being used at non-optimized times. And I'm just like, I have no concept of that in my house. Like we're just So inefficient.
We converted to a time of use energy plan last year. So like any of the major appliances, I'm watching them, and when they get turned on during that peak period, all the Amazon Echoes in the house basically nag and say, hey, you know, don't run the dryer between 4 and 8 p.m. And then it texts me too, so I can go yell at whoever it is.
I love that.
And Cam, you touched on an interesting topic there, saving power. So you already heard that I got solar panels on the roof. I try to be conscious of my carbon footprint. I'm going to show you guys something here. So I've got an automation that controls all the lights in my office that actually runs off the amount of light coming through the window. I'll get to that in a minute. But before I do, I want to show you some of the stuff that I've set up here. So the office light bars, they're behind my monitor. They're kind of lighting my face right here. The office LEDs is the strip that's across the top. The office display lights here, that's these lights behind me. Now, you can see it's only like 20% there. What's interesting about most LED lights is you can feed them like a fraction of the percentage that they're normally fed, and they'll be full brightness. So if I go take this guy right here and turn it all the way up, come on, no change in the lights behind me. Let me go click this one, make it a little more clear. No change, no change. Down here, they got a little dimmer, right? So I can run this very low power, and almost every LED light in your house is going to be like this. You can kind of figure out what it is for that light. It's going to depend on it. I've also found that you can dim pretty much any light in your house. So most of the smart switches, they don't work. We're going to get a little electronic theory here. I'm not an electrician, but you know, current in your house is AC. And old dimmer switches used to change the amplitude of the waves to dim your lights. New smart switches, what they do is they're the full amount, but they chop the wave. Mm-hmm. So it like shortens up, and it's like it'll go up and then cut it off. And that's how it does the dimming. And LEDs, they want a pulse of light anyway. So as long as that pulse is going to them, they're going to do their thing. And so you should shorten the amount of that pulse, how much they get, and you can dim the lights. The lights in my kitchen, they're not dimmable bulbs, but they dim almost all the way up and down. These ones behind me, they're a little more sensitive. And so if I set this down at like, I don't know if you can see that, they're flickering really bad back there. So there's kind of like a minimum that you need to find for them. Well, I want to control all the lights in my office together. And Home Assistant gives you a way to do that. They got this thing called a light group. So I've taken all three of those lights that I talked about, and I put them into one group, and I can change them here, and it'll change the ones behind my monitor, the ones behind me. But this is going to suffer from that problem. If I get down in here, those are going to flicker real bad. So what I've done is I've created a virtual light, just like these virtual lights over here. And that's this combined lights one. This is a virtual light. It triggers an automation. The automation goes, what's the light setting? And so the lights behind me will actually only come on if this thing is above 50%. So if I bring this down to 49, those turn off. And if I go to here, they go up. And actually, what I can show you here is by controlling this, you can watch all three of these things change at different rates.
That's really cool.
Now, the other thing is, like, some of these lights are colored, some of them are not. The LEDs above my head and the ones behind me, they're color lights, but these ones aren't. So I've made my automation send the color signal to the lights that are appropriate. In addition to that, I've got a motion sensor sitting right next to me that's also got an luminance sensor. And this took quite a bit of work to set up. This was a little more involved. The automation that triggers when the luminance in the room changes, it knows what the power reading is or what the percentage level of this group of lights is. And it will subtract that from the light, from the sensor reading. So it'll know how much is light coming actually through the window. That took a while to calibrate. And then it'll use that to adjust the lights back up to a target brightness. So this slider here, let me turn off the office override. If I set it down here, you see the lux up here is 129. That's what the luminance sensor is. So this is looking for that target illumination. So if I get it close to 129, the lights come on a little bit. And if I turn it up there, they turn on a lot. Next cool thing about this framework that other frameworks can't do is there's this thing called an automation mode. Home Assistant's got this kind of thing where if your automation is triggering, if the entities are updating their state faster than your automations can run, what do? Now, the default in Home Assistant is anything that's new, if your automation is running, it just throws it away. That's single. I've got that mode too. There's also parallel, all the same modes that Home Assistant has, but I've got one more mode. It's called Smart Mode. And if an automation is running, it'll drop it, but it'll track it. It's like, that's a state change. So 2, 3, 4 more automations or state changes can come in. And when the automation finishes, if there's anything that is tracking, it'll run it one more time to make sure it always catches the latest state. Now, this isn't normally an issue, but here's a case where it might be. So I want you to keep an eye. We're at 129 lux. I've set my target illuminance to 10. I've got that guy selected. If I push the arrow key on my keyboard, this is going to fire a whole lot of events very quickly. And so this is actually making 2 trips through the system. One to change the combined lights and another one to set the lights in the office. So it's actually 2 automations that are firing in succession right now. And of course, now it's going to, sometimes, there it goes. Like I said, it takes a while to calibrate it and figure out what it's supposed to be, but yeah, it's fast.
So for the parents out there, Robert has shared in the chat an interesting use case here. I'll pop it up. I got a laugh out of it. Robert says, I have my LG TVs and Home Assistant as well. I'm thinking of coding an automation that if an entity is set to on, it will not allow the TV in the living room to stay on. He goes on to say why. I have a 15-year-old that likes to sneak out and watch TV when I'm asleep. So the takeaway here is home automation can help you parent while you are sleeping.
Yeah.
Love that.
No, that's what got me started on this whole journey. Actually, was we have a walk-in pantry, and what would happen is the kids would walk into the pantry looking for a snack and find whatever they're going to find, and then they walk out and they just leave the door open and the pantry light be on, and you know my dad instincts would kick in and who left this light on, you know. So I said, you know what, there's got to be a technical solution to this, and that's when I got my first Z-Wave sensor and Smart Things at the time. Now I've since moved on from Smart Things as a platform. I went from Smart Things to Habitat and now to Home Assistant. But yeah, that was my whole impetus for getting into home automation to begin with, was parenting. In fact, probably I've got a good number of automations that are all just yelling at the kids for various things. You know, you left the back door open, make sure the gate's closed, so the dog doesn't get out, that kind of thing.
You might like this one. My kid's name is Asher. I've got a button in the dining room. And when I push that button, it plays one of those messages in his bedroom.
That's awesome.
That's amazing.
And just in case he's got his headphones on, I can't hear it. It'll also flash the lights around in the basement.
Brilliant. Just brilliant. We have so to make announcements in our house, so because we've got 3 sons and a nephew living here. So there's 4 young men ages 15 through 25 living in this house now. And So it's often that we need to get an announcement out to everybody. But of those 4, 2 of them refuse to install any Home Assistant apps on their phone, so we can't send them notifications, and they refuse to put an Amazon Echo in their room, so they can't get audio notifications. And I'm like, okay, you're making this parenting by automation difficult, guys. But what I eventually did was I got a Twilio account, right? And now if my wife or I send a text to that Twilio account, Home Assistant will pick up that text and it'll forward it as a notification in Home Assistant. So that gets the ones with the Home Assistant app. And it'll send a text to the phones of the other 2. And on top of that, it'll make an announcement in every room in the house.
So as an example, I just had on the screen an automation. So if you saw it up there, it's going to play a message. Should be on the speaker right here.
Writing home automations with C# is easy.
So it's just that much. I know we're coming up on time. There's a couple more things I would love to get to real quick.
By all means.
So one of the things that I found was when going through this is sometimes it's difficult to troubleshoot. Like you send off a message into Home Assistant REST API. How do you get your observability into it? And so I did write for, this dashboard. You can get in here and see all the different ones that we have. Do I have? So this is the one that's running local. So I have the this one. That's the scene controller. Button 2. This is the one that just ran. So when I push that button, this is the automation that ran. Any logs that you set up, so just use your normal iLogger. It will capture all that stuff here. You can, of course, set your log levels. There's all kinds of stuff in the documentation about what stuff it records out of the box. And this was great, but I wanted a little more observability. So I went ahead and wired up OpenTelemetry. So
nice.
Out of the box, when you use HaKafkaNet, you can configure your OpenTelemetry. That looks like, come over here to program. So we've got metrics and tracing. So it keeps track of all of the different entity changes that you have going on in your house. It will actually record all that stuff. You can keep track of traces. What I found that's interesting about the traces is if my automation is slow, it's probably because it's the Home Assistant REST API that took a while to respond. And then with all this stuff, I was actually able to gather data on my system and found out that there were a bunch of entities in my house that were firing off thousands of messages. And not only was it a bog down on the system that I was writing, it's a bog down on Home Assistant itself.
Right.
I'm running this thing on a Raspberry Pi. So by getting this stuff into telemetry, I was able to set it up with a Grafana dashboard. So I've also got Grafana that's running locally. So in the last 12 hours, these are all the automations that we're running. Looks like it's down right now. That can sometimes happen with my collector. I haven't figured this one out yet. But if I can go back like the last 7 days, these are all the automations that I had triggering. These are all of the entities. And this graph here, I was able to reduce the amount of traffic by devices in my house by roughly 90% by simply disabling entities that I wasn't using. So like my ESP32 wave sensor, out of the box, I had like 15, 20 different sensors, like how many people are moving, how many people are sitting still, and it could do that for multiple zones. It was like, I don't care. So that one device had like 20 entities, and I disabled like half of them. I went through my home and I found which ones were being the most chatty on here, and just one by one went through and was able to reduce the overall load on my system.
I ought to do that exercise. I've got something like 2,600 entities in total now, and I know there's quite a few of them that just sit there and do nothing other than, chat all day.
Mm-hmm. Yeah.
Well, maybe they get lonely. They just want to.
Actually, to write some automations in Home Assistant, I had a time of day sensor. And so this was an entity that was just like every 6 seconds, it was like reporting. The time changed. Since I moved everything to .NET, I don't need that sense anymore. I got rid of it.
Nice. Yeah, so back when I did Habitat, and Leonard, when you and I spoke, a few weeks ago, we talked about this. Back when I did Habitat, I had kind of a framework. It wasn't nearly as in depth as HaKafkaNet, but it was kind of a loose wrapper around Habitat, built in .NET called Puppet. And one of the most useful things that I got from that was the ability to integrate Azure application insights to get some of that same kind of data that you're talking about, like how what entities are the chattiest and so forth. I could really use that functionality in Home Assistant, so I'll be looking at that for sure.
Unfortunately, we're at time, but I wanted to squeak in one last question from one of our viewers here. You see up on the screen here, I'm currently using OpenHAB in a Docker container with all my config and automations checked into Git. Does anyone have a comparison of how to do that with home automation and if it works better?
That's a good question. I mean, obviously, HaKafkaNet, the automations are done in C# and that can easily get checked into Git. Out of the box, Home Assistant automations are all stored. I think they're all stored in one giant YAML file, and that you can back that file up and check it into Git and everything. But I certainly, using something like HaKafkaNet would be a lot easier to get that into GitHub or whatever.
All right. Thanks for that answer. And thanks to our viewers for all the questions throughout the show. Really appreciate it. Thanks again to Leonard for sharing his expertise over the last hour.
Yeah, I've been really looking forward to you coming on, Leonard. I'm really glad you, really glad. Well, the way this all started, just to interject before we close out, Leonard came to Reddit, to the Home Assistant group, the subreddit, and hey, check out the latest release of HaKafkaNet, and a lot of people are like, why do I need this? Why do I need C# and in Home Assistant? And I just flipped over it, and I reached out to Leonard and said, Leonard, come on our stream, please. So I want to thank you, Leonard. This is outstanding. I love this project, and
thank you for having me.
And you are very, very much a person after my own heart. I'm looking at all those Star Trek and Star Wars collectibles behind you and the home automation. And I have a feeling that you and I could just chat for hours.
Mm-hmm. I'm sure we could. So yeah, come check out the GitHub repository. I know the link is on the stream already. On there's also a link to a Discord channel. So if you've got questions or need help getting things set up, go ahead and hop on there, and I'd be happy to help.
Thanks, Leonard. And for our viewers, tune in next Monday, same time. We'll be joined by Santiago Arango Toro, who will join the show, and we'll talk about Azure Container Apps, .NET, and Dapper, not the micro ORM, but the distributed application runtime. Hope to see all of you then. Thanks again. Wow.